Okay, pre-calc fans, today we are looking at what are called log equations. So first thing we got to do is let's review our log definition and log rules. Remember, the log is just an exponent. So log base b of n equals x is the same as b to the power of x equals n. Okay, those are the same. Remember our first log rule, the log of a product, log of a times b, that's the log of a plus the log of b. Then we had the quotient rule, the log of a over b, which is equal to the log of a minus log of b. And then we have our power rule. The log of a to the power of p equals p log of a. So that exponent becomes a coefficient. Okay, so what we're going to be doing is we're going to be looking at these equations. Okay, these types of equations right here, this first three that I have in front of us. Okay, in these pieces right here, every time you're doing these problems, your log, notice how these all say log base 3, log base 3. When we're doing these problems, our bases will always be the same. We'll never have a problem where we are using different bases. Okay, so we have three basic rules. Okay, rule number one is we're going to express each side as a single, that's a key, log expression. So we're going to express each side as a single log expression. Okay, then we can cancel the logs, and then we check. We solve and check. Now, the key for checks is the following. There are certain numbers that we cannot take the log of. We cannot take the log of negative numbers, and we cannot take the log of 0. Log of 0 does not exist. So, no, all of these followings, okay, logs of negative numbers, log of negative numbers, or 0. So if you have x equals 0, we can't keep it, okay? Actually, it's not that x equals 0 we can't keep, it's just a matter of how it's written out. If it says, so we have certain things we have to be aware of. Okay, we can't take the log of negative numbers, and we cannot take the log of 0. And the other thing, the base, we cannot have, so no base of a negative number. So these bases right here cannot be negative or 0. Okay? Or 1. Cannot have a base of 1. Okay? So in other words, when you're doing your checks, your base is always greater than 0, and it cannot be 1. Okay? And then for our x values that we're looking for, all of your x's have to be greater than 0. So that's your domain. Your x has to be bigger than 0. Okay? All right, so there's a lot going on over here with our check. All right, let's look at problem number 1. So we have to write this side right here as a single log expression. That's right, it says plus, so that we just write log base 3 of this product, 5x. And if you want to, put parentheses around it. You don't have to. And then over here, log base 3 of, that's right, hopefully you'll say 16. How did I get 16? That's right, log, the log of the sum, it's right here. This is your product rule. Okay? The log of two sums, the log plus a log means this is your product, 2 times 8. All right, now notice, here we are, we just took care of step 1. We wrote each side as a single log expression. Now we're going to cancel the logs. So I'm just left with 5x equals 16. Divide by 5, problem's done. X equals 16 over 5. Or we can change it to a decimal. It's a nice decimal. Then we're done. And now, is it bigger than 0? Yes, bigger than 0. There's no negative numbers here. Okay, we're all set. All right, now, writing this as a single log expression. Well, the very, very first thing, oh, by the way, I can move logs left and right on this side of the equal sign. Okay, so if I wanted to move log base 4, this log base 5 of 4 over to the left-hand side, it would become a negative, no big deal. All right, so this problem right here, we have to take care of this coefficient first. We cannot deal with coefficients. That's right, we have to rewrite coefficients as exponents. So the very, very first thing that we're going to do before, in the process of writing each side as a single log expression, this coefficient of 3 has to become an exponent. Now I can write this side as a single log expression. So log base 5 of 27x to the power of 3. I'll put that in parentheses. Equals, right, the right-hand side is log base 5 of 64. Okay, 4 times 16 is 64. That's right, your log base 5s are the same. We can cancel them out. So I have a nice, easy equation to look at. 27x cubed equals 64. Now just a little bit of solving. Okay, that's right, divide by 27. I'll leave it as a fraction. This is your power equation. And then, what do? Yes, we could take the cube root of both sides, or raise each side to the 1/3 power. I don't know if you guys can see that 1/3 or not. It's getting a little messy in there. Okay, so then you can easily type this into your calculator, 64 over 27. Make sure you put parentheses around both. Raised to the 1/3 power. And you get 4 over 3. So x equals 4/3. Okay, easily type that in your calculator. Okay, that's right. Remember, I got rid of the 3 here by doing the 1/3 power. I raise each side to the 1/3. I know it's hard to see there. Okay. Apparently, I didn't give myself enough room to do these problems. All right, last one. Uh-oh, there's some minus signs in here. That's right, that's your quotient. So log of x over 6 equals log of 5/3. Okay, so I can drop the logs. Notice they're both base 10, no big deal. So I have x over 6 equals 5/3. And how do we solve this? That's right, all we gotta do is cross multiply. Actually, I'm just gonna multiply, I'm gonna do 6 times 5. So I have 30 over 3, which equals 10. And we're done. Notice our checks. None of these came out as, there was no negative numbers here to worry about. Okay. So we just took care of when we have logs on both sides. Now I'm going to turn the paper over. And now we have logs on one side only. One side only. So what do you think we have to do? That's right. We have to, so first of all, by the way, if I had this log base 3 of 4 on this side of the equal sign, let me put it over here as a negative. Okay, we have to group all the logs together. As you look at this problem right here, you see, oh, this 5 does not have a log in it, so we have to group. So maybe rule number 1, I should have put this down for rule number 1, group all your logs together. Get all your logs on one side. Get all logs on one side. So that means I got to move this negative log base 3 of 4 over to the left-hand side. So I have log base 3 of x plus log base 3 of 4 equals 5. All right, now rule number 1. So let's call that, never mind. Put that as a star right there. So now rule number 1 is express the one almighty side, the one ring, the one side as a single log expression. Okay? Then, all right, so let's do that. So I have log base 3 of 4x equals 5. Now what do you think we have to do? That's right, convert to exponential form. Convert to exponential form. That's right, that's this. So here's your base, here's your exponent, there's the number. Okay, so I'm going to do it over here. So I have 3 to the power of 5 equals 4x. And now I can just solve. Okay, and then the rules are the same. So we have no log of 0 or negative number, and we cannot have a base of 0 or negative number or 1. Cannot have a base of 1. All right, well, 3 to the 5th, huh? You have your handy-dandy calculator for that. That's 243 equals 4x. Then you just got to divide by 4. So x equals, I'm going to leave this as a decimal, 6.75. 60.75. There we go. It's not 0, it's not negative, and we're all set. See, we weren't looking for a base here. All right, let's look at this next one. Oh my God, this looks wacky. But who cares? 2x minus 3 is the base. Isn't that the exact same base? So it's already on this side. There's no moving things around. So express this side as a single log expression. So the base is 2x minus 3. 2 times 3 is 6. Equals 1/3. Well, that's not hard. This is the base. So now I'm going to write this in exponential formatting. So there's the base, there's the exponent. So it's 2x minus 3 in parentheses to the 1/3 power equals 6. Well, that looks pretty easy. Now how do I get rid of the exponent? That's right, raised to the 3 power. So I have 2x minus 3 equals, well, 6 to the 3rd is 216. And now I just add 3, divide by 2, problem's done. So 2x equals 219, I divide, and I have 109.5. Now if I plug in 109.5 right there, does it give me a negative number? Does it give me 0? Does it make it 1? No. We're done. All right. Got a lot of algebra in this one. Well, let's see what's going on with it. So log base of x plus 2. And what am I going to do with these two? That's right, we have to multiply them together. If you can do it in your head, great. If not, you got to write it out on your own. This one right here, I got this from 4x plus 1 times x plus 2. Okay? If you have to do your box technique for multiplying this out, you got to do whatever you got to do to come up with this answer, okay? You should be able to do that. Equals 2. All right. We did the easy stuff. Now we have to do more easy stuff. Just got to put this in, convert it to exponential form. So there's your base, there's your exponent. So I have this equals x plus 2 squared. This is just algebra, folks. Pretty easy algebra, too. We've squared stuff like this before. And now it's a quadratic. I have to make it say equal to 0. All right, where did the 3x squared come from? That's right, I subtracted x squared and the 4x squared. Where did plus 5? All right, I subtracted 4x and the 9x. And where did the negative 2 come from? I subtracted 4 from the 2. There we go, equal to 0. Now this one's a nice easy one for to factor. What are your only factors of 3? That's right, 3x and 1x. What are your only factors of 2? That's right, 1 and a 2. So we have to put the 1 and the 2 in the right spot to make sure we get 5 in the middle. Don't forget, we got to play with that 3. And hopefully you'll say you put the 2 here, 1 there. 3 times 2 is 6, and it's got to be a positive 5. So plus the 2 minus the 1. So I have answers of a 1/3, and I have an answer of a negative 2. All right, now we got to see which one we can keep. Maybe we keep them both. Maybe we have to throw them both away. Okay? So let's see which one we have to keep. Let's see, what happens with, let's look at the negative 2. What happens when I plug in negative 2 right there? Well, negative 2 plus 2 is 0. Well, remember, we can't have a base of 0. So negative 2 is certainly out. So now 1/3, right? There's nothing wrong with 1/3 there. That certainly doesn't make it negative or negative numbers. I'm adding I'm plugging in 1/3 there. You're adding 1, you're adding 2. Guess what? 1/3 is our answer. That is our rules and our methods of solving log equations. All right, folks. Have fun with your homework.